Alright, so today I'm going to start looking into how to actually go through the process of making put up a package on Hackage, so to speak, and actually um, publish this sort of generalized Dijkstra idea I've been working on. I think eventually it might grow into a more generalized algorithms. But I'm kind of thinking I'm going to start with just the simpler version and probably end up deprecating that eventually if I add on to it. So let's just start doing stuff. Publish to package. Loading packages and package candidates. So let's read this. This cannot be undone. Try to get it right the first time. Package candidates feature used below. Each package has a cost of operation associated. For others. Must be in the form produced by Cabal's sdist command. A gzip file version containing packages. By default, upload packages are curated. Means both maintainers and package trustees may revise their metadata to guide build tools in producing install plans. In order to ensure integrity and well-functioning of the Hackage Cabal ecosystem, all curated packages should follow Haskell's package versioning policy, probably just semantic versioning, some version of that. Although PvP and Semver are based on the same concepts, they differ significantly in structure and consequently are not compatible with each other. That's interesting. Okay. so something that is immediately contradicted by the next paragraph. For more details about the differences and related issues. Further, an important property of the PvP contract is that it can only be effective and provide strong enough guarantees if it is followed not only by an individual package, but also by that package's transitive dependencies. Consequently, packages which are curated should aim to depend only on other curated packages. I'm not worried about that. In the course of the curation process, the package trustees need to be able to contact package maintainers to inform them about and help resolve issues with their packages, including its metadata. Package uploaders may choose to exclude individual package uploads from curation. Open source licenses. Code and other material you upload and distribute must be under an open source license. This is a service operated for the benefit. Policy. See the one Cabal breakdown. I mean, I assume the default one that we get is, which is the SD3. Yeah. We'll need a package, username and password. Package candidates are a way to preview the package page. view any warnings or possible errors you might encounter, and let others solve before publishing to the main index. These warnings with the Cabal check. You can have multiple candidates for each package at the same time, so long as they each have different versions. Finally, you can publish a candidate to the main index if it is not already there. Package candidates have not yet been fully implemented and are still being improved. Interesting. Source bundle builds, including the package documentation. Basic library. There are some notes for upgrading much older packages as well. Okay, so these are the general instructions. Let me read this stuff about the versioning policy. Package might affect them. Keywords must. It's not marginal. May actually have any number of additional components. Interesting, this is should and not shall. Version number ordering is already defined. Need your version number and see the minor version number. If any entity was removed, or the types of any entities or the definitions of data types or classes were changed, or orphan instances were added, or any instances were removed, then the new A.B must be greater than the previous A.B. Okay. If only new bindings, types, classes, non-orphan instances, and modules, A.B may remain the same, but the new C must be greater than the old C. Okay. Other changes, corrected documentation, non-visible changes may remain, ABC may remain the same. Other version files may change. Since ABC uniquely identifies the API, the client wants to specify that they depend on a particular version of the API and specify a particular ABC. Client may specify their insensitivity. So there's a case where additional removal of a package. Okay, this is getting into the weeds. shall ensure that your dependencies and build dependents are accurate. Okay, so this is actually going to be the tricky part, and something that I'm definitely going to want to spend a fair amount of time working with, which is, you know, I've done this all with a particular package and like, you know, stack.yaml, and so I haven't included anything new, but I'm also going to have to figure out, okay, what is the range of acceptable the range of acceptable package numbers on these. Can I use, like, if we just go to containers? Oh my gosh. If we just go here. Like, this one is all, I feel like I almost certainly am using 0.6.6. Would it work if I use 0.1.0.0? Maybe it would. I don't actually know. So I have to, it depends on, I'd say probably like at a minimum I should probably go down to 0.6 because this is a different major version, like, or 0.5.11 would be a different major version, and so I should think about just doing this, but it might still be compatible with this API, so I don't know how to necessarily make that work. So yeah, that's definitely a challenge. But regardless, I'm gonna, like, some of these I probably won't actually need. Like, I'll need containers and another containers. I'm not sure I'll actually need array. I'll need heap. MTL, actually probably not. Like, and you know, there will be different tests and benchmarks that I can include with it, but that won't actually be published. That won't be part of Haddock API. But regardless, I can sort of make another another list here. So essentially saying, like, hey, how do I do this? So, 1, make a new repository. 2, module layout. 3 is going to be, you know, determine module layout, copy code, copy tests. And then there's going to be a lot of time that I spend sort of writing documentation. And then I'm going to have to run version constraints, and then it'll be something like, okay, make package candidates. And now go through publish process. Documentation, which is going to include Haddock, and it's also probably going to include examples. So yeah, that might be sort of the idea. So as far as what code is actually going in here, like, it's pretty much just going to be this module, not even everything in this module, most of this example code down here. is not going to be part of the public API. That'll be, there will be examples in the test module, but otherwise, like I'll definitely want to have 2 examples laid out on the project description page. But that's pretty much going to be it. I'm not going to include these particular instances as part of the public API unless I end up doing like a separate unless I end up doing a bigger algorithms library. But I think I'm going to do a deeper exploration of some of these advent of code problems, and so say, okay, what algorithms do exist here? What would it make sense? What could I actually contribute that doesn't exist already in the broader Haskell ecosystem? So yeah, I'll sort of decide that later. But anyways, the way I'm imagining this repository is going to work is algorithms.dijkstra and algorithms.dijkstra.org. And this question of, do I want graph distance to be the actual return type, or like, do I want that to be the exposed return type, or do I want to impose a bounded constraint on whatever metric that the user gives me? That's another option. Probably the latter. Like most types that we give are bounded. That's another interesting. So I have to decide that API question. So copy code, copy paste. Questions like, okay, is that way? I wonder if some notion of that already exists in Haskell, where it's like, oh, is there a sort of a built-in type Haskell numbers with infinity? Transplant data.monoid.in monoid extras. I don't know if I want. It doesn't necessarily seem like it's. None of these look like they are used all that commonly. Fractional. We're trying to say infinity. So there isn't. That's so weird. We're never finding over infinity. People tend to forget about floating point infinity, which I did. I totally forgot. Which I totally forgot. I totally forgot that floating point infinity exists as well. But I don't know that I want to. I'm wondering if I would want to impose a floating point constraint, because I feel like a lot of people are going to want to use this, or at least the way I intuitively think to do a lot of graph problems is with integers rather than the way that forcing us to use infinity as a floating point value. So that's another question to answer. But these are going to be the only really public facing modules, and we're going to expose the Dijkstra graph class. No, I don't need where. Find shortest path. Find shortest distance. Maybe I do want to expose this. I don't know. And then, you know, find shortest path. I kind of like this API. And these are going to be the same. It's all going to be the same. Actually, the graph itself, it's actually not a problem. Maybe I'll have another one that's and this will have the Dijkstra graph class, but it'll be re-exported through everything else. And so these will just have all these functions just with different, just with the different constraints. So, okay, so this makes sense as my general layout. So let's actually go into Ubuntu and here's an interesting question. Do I need to name the do I need to figure out the repository name already? That's an interesting question. Because I wanted to say, you know, stack new Haskell Dijkstra. So we go to source, vector algorithms, and so we'll have oh, now I'm going to run into my problem. Well, actually, no, I won't. Because what we'll have here, we'll have graph. I'm not sure I'll actually need that much in the way of internal stuff. So I have those, and I wonder if I can. Is this just going to work? Import lib. You don't need an executable here. But okay, so that's the overall structure. Alright, let's actually open up. So now let's go back into our advent of code. Wait. So let's go ahead and grab this. These want type families. So I get separate Ubuntu into because I don't want to close all this. Okay, so that is working so far. And now I need to, actually no, I already have this file. And what are we going to do? We want to import pretty much all of this. And this is going to be the okay, for all or similar language. Well, that's interesting. What language did I actually use in here that allowed for all? Was that scope type variables? Okay, oh, it was, apparently. Also, we do need our graph distance for now, at least. Whether or not we're going to use that. So we also just need set, and we need keep, and we need hash map. If you have set, so that means we need unordered containers, and we need keep. How are we doing? And now we need some more, we need flexible contexts. And it compiles, surprisingly. I'm surprised I only needed 2 extensions to do that. But okay, so this stuff is potentially private, but I'm still, yeah, because I'm returning, I think I'm applying the boundary constraint here. But anyways, okay, so this has been interesting. Starting to actually like package some of this code up in a way that I could eventually export it, but maybe I'll come back to this next week. I'm going to have to sign off for now, and there will be no streams this Thursday or Saturday, so I'll be on vacation. So thank you very much for showing up, and have a good week.